Good morning, good afternoon. Thank you for joining today. Welcome to another exciting webinar series. Today we are going to be covering our Versatronik 503, which is going to be a analog communication bridge module, or an NR2. The NR2 and the analog bridge communication module. We are going to go through and identify the intended use of this Versatronik 503 control. We'll explain the wiring protocol for this control. Quick intro to it. It does take our LAN communication and allows us to take our some current and some legacy products that use our LAN communication and transfer that to a CAN bus communication, which is used in our new E series. So that Viessmann 200E or the CI2 models. And we'll illustrate the communication possibilities between those legacy, say a B2HB, CM2 models, and things of that nature. So it is just a very small control, as you can see here, and we are going to wire this in to give us some more information on it. So the intended use of this analog bridge is to integrate a boiler equipped with our one base controls. That would be our E series boilers. So that new Viessmann 200E, the Vito Crisol CI2 also has the E series in it. Now the Viessmann 100E series also does have one base controls in it. However, that's not a cascaded boiler, nor does it have LAN communication. So this is going to be for that 200 series and the CI2. And we're going to put these, when we're retrofitting and maybe only have to replace one boiler, we can make sure that we can communicate between those two different communication protocols. On the LAN side, the Versatronik behaves like any other boiler in the cascade. So it's just going to communicate with those MW2C controls, GW6B or C control, depending on what unit it's on. That is going to receive the LAN communication and deliver to the target boiler a 0 to 10 volt temperature demand. And it relays back to the main cascade control the following parameters. So we're going to get a boiler temperature based on the installed strap-on sensor that's going to be included. We're going to put that right on the supply pipe of the target boiler or boilers. We're going to get a modulation rate of that boiler based on the 0 to 10 volt burner position feedback terminals. And we also will get fault statuses through that. So it's going to take that CAN bus, give us a little bit of information. We're going to change that over into a LAN communication, so it'll feed back to that original lead control or lead boiler. Now, we are going to just remove a couple of side cover screws here, so two left and right, and then we'll be able to mount with those 4 screws to its mounting location and a convenient location that we make sure all those sensors are going to be able to get to everywhere. Fasten that wall to the back of the boiler, side of some of the boilers. Make sure we're not screwing into any connections, wires, or anything of that nature. You can put it on the wall behind the boiler as well. Once all the wire connections are verified, we can go ahead and reinstall that front cover. It has a bunch of knockouts in there for top and or bottom wiring. Now, what we're going to be doing in here is we do have a power supply. And the power supply is going to come in down here. So we do have to have a 120 volt power supply. It has a pre-installed 6-foot convenience plug just to plug into a service outlet that hopefully is there for your drop lamps and shop vacs and things of that nature. We have a LAN connection. So 2 LAN connection RJ45 plugs here. One is going to be receiving the LAN communication from your lead control or lead boiler, and the other one is going to have an end-of-line resistor in it. We're going to have a 0 to 10 volts temperature demand. So this is going to be the boiler command. This is what's going to take the information from our LAN, give it a 0 to 10 volt, and this 0 to 10 volt goes to the boiler's 0 to 10 volt input location. We have a fault message output from the boiler here. We have a boiler temperature demand, which are temperature reading, I should say, with that strap-on sensor here on terminals F. And the boiler status of the 0 to 10 volt burner position feedback is going to tell this unit exactly what modulation rate the boiler is currently at. We're going to be able to read the boiler's temperature, any active fault codes, and then change its 0 to 10 volt signal accordingly. We are also going to have a rotary dial here. This rotary dial, or S1 rotary dial, this is how we're going to address the LON participant number. So is this going to be, typically it's not going to be boiler 1. So boiler 2, 3, 4, up through 8. Remember, this is going to act as a full boiler or burner, and the LON communication can handle up to 8 burners. So this would just act as one of those 8. The dip switches here on S2, all of these dip switches is how we're going to tell the Versatronik 503 control what size unit. So the model and the BTU size of the unit, we'll look at a snapshot of this with a couple of the models on there. Obviously, all of the models are available in the manual. Then there is also an outdoor air sensor simulator. So we have an outdoor air temperature simulator here. This is going to be used for very old legacy equipment if it is still out there. There's no reason to replace all of it if necessary, but some of them we need to simulate an outdoor air temperature sensor. We'll look at a very quick slide on that, very last slide that we'll use. So as I mentioned, the LON participant number is going to be in this rotary dial here, and we're going to rotate that rotary dial into whatever boiler that address is. There is kind of an auto binding reset option on that terminal 9. You can follow the directions here to kind of reset that positioning to change the boiler address if necessary down the road. The 2 RJ45 jacks that I mentioned, one's going to be filled with the communication plug from that lead control lead boiler. The other one is going to be used for that end of line terminator, end of bus connection, needs that resistor. Installed in whichever open jack. It doesn't matter which one you put the resistor in and which one you put the communication in. The end of line resistor is not included with this package, as it should already be installed on the current boiler that you would be removing and replacing with the newer E-series boilers. So make sure we do grab that end of line resistor off of the old boiler so that we can put it back into the new boiler in this 503 control. The dip switches just below it, if we were going to be replacing this with a B2HE85, we would do on, off, off. If it's a 120, a 150, a 199. And then furthermore, you'll get a CI2 399, a CI2 500, the 750, 1 mil, 1.5, 2 million. Different protocols for, you could also use this with a CA3, CA3B. Although that boiler is still in current production, maybe a possibility of changing it over into a CI2 down the road. So there's a possibility to use a multitude of boilers. And just, again, a quick snapshot of what your options would be. Please refer to the install manual for all available options. They are and will be listed in there. Now, for the boiler connections, on the 200 series, whether that be the Vito Dens or our CI2, they are both the 200 series. On the MZIO board, so this is where we're going to be doing most of our field wiring in the control anyways. This will be located right with that HMU, that heat management unit. And in the Versatronik control, we're going to be looking at our burner position feedback. So this will be your 0 to 10 volt output. And that 0 to 10 volt output, we'll use the 2 wiring connections here, and we will bring those over into our boiler temperature location. We have our 0 to 10 volt input, which we're going to bring over here to our boiler demand, boiler command call. And we do have to make sure that once we power this unit up, this E-series boiler up, we do have to ensure that we go to address 1706, VDD 1706, and ensure that's where we turn on 0 to 10 volts. So we have to make sure that we go in there and turn it to a temperature demand. so that the boiler will respond to this 0 to 10 volt call that we are giving it. We do have a fault message output, so that fault message output is going to be wired to S and P. S and P would I'll have to check with this, but we are going to wire to this plug 66. So when we're at address 1706 and we're going to engage the 0 to 10 volt, we're also going to tell the unit that it has a fault message output, where we would say, I want fault message output and temperature demand would be your option at address 1706. And then we're going to wire this to its normally open terminals. And anytime a fault message occurs, it's going to close that relay, and this will be alerted that there is a fault. It's not going to tell you what the fault number or code is, but you will get a lag boiler fault off of your lead device, lead control, lead boiler. We do have that strap-on sensor that we do need to, so the 10K sensor is supplied. That's that strap-on sensor that will go into your supply piping just exiting the boiler itself. Now, what we would do if it's a B2HB, I guess it could also be a B2HA, again, still a current boiler, so you'd probably replace a B2HA with a new B2HA, but maybe there's mitigating circumstances, so we could add a B2HE into that package in that cascade system. So we have that MW2C on site that would have your end-of-line resistor in it. This is going to go over to each boiler independently, daisy chained through them, and that 503, as we just saw, communicated. So that's going to receive our LAN communication. It's going to transfer it to a 0 to 10 volt call to bring the boiler on, and then this is going to report back to the MW2C supply temperature, modulation rate of the burner, and feed that back so it knows when to shut it on, turn it off, and run in that algorithm. It doesn't have to be on the end of the line. It could be a middle boiler. If we're doing a package of CM2s with 4 CM2s and we had to replace one boiler for whatever reason the case may be, we can put this in any location we want, just ensuring that we do make sure we set that rotary dial to the correct location for the boiler 3. Make sure that would be set to number 3, and then also the dip switches. Make sure the dip switches get set to the right protocol so it knows that it is a CI2, and also the BTU count of it. It will take that into consideration in the algorithms. Now the VitoGate 300 BMS, so our BMS integrator that was used for all of our LAN participants and LAN controls, it will not recognize a Versatronik 503. It can't correctly communicate, or it cannot directly communicate with the target boiler. It can retrieve data points. So you can read what's going on, but you won't be able to write or do anything to that Versatronik 503, but it will report your information back to it with your output values, water temps, water temperatures, boiler faults, and operating modes. You can still get those read-only points. And lastly, if we do go into some really old legacy boilers, the older, Vitodens 100s, WB2As, applicable boiler models that would use this. This is an outdoor temperature sensor simulation. It's meant to be used for boilers that don't have a 0 to 10 volt capability. So the terminals to provide a resistance output that would simulate an outdoor temperature sensor. So since I can't feed this with a 0 to 10 volt, we're going to change the reset curve so that we have our points that we can hit along the way. So it's not going to be a fully curve that reads every temperature, but it's going to have stages that it can go through to simulate outdoor temperatures as if we were giving it, say, a 0 to 10 volts. So those are in a lot of those old legacy controls, as well as, a Vitotron, VLN2, that's our new electric boiler. So if we needed to use this as maybe even a backup as well, there are some other things we can do to use this control in functions that aren't really using a LAN communication or a 0 to 10 volt input as well. So there are some last considerations that we might be able to use this in different applications. So identify the intended use of the Versatronik 503. I know this seems like a short webinar. This is a nice little bridge that we have so that we can keep those old systems in play if we do have the unfortunate circumstance of replacing them. So the intended use to take our LAN communication protocol boilers and integrate our new CAN bus communication, those E-series boilers. Went over the wiring protocol from LAN to CAN bus. So it doesn't actually really go to CAN bus, although I wanted everybody to understand the two communication differences between our new boilers and our current and legacy boilers. So CAN bus in the E-series, LAN in the some current and legacy boilers. Now, there is a possibility with some of those B2HA controls that you might not have a LAN control package, that you might have a KMK control package. Those are able to be updated from KMK to a LAN communication protocol, and then we can have that LAN communication talk with the E series. So there is a bunch of stuff that can go back decades, and we can still have those boilers in operation and only replace what's necessary instead of an entire cascade plant. And again, those communication possibilities are quite endless with all of our old legacy models. Again, even looking at that last slide with like a Vitodens 100 or that electric VLN2 boiler that don't accept a 0 to 10 volt signal, but we are able to do an outdoor sensor simulation. So we're able to adjust that temperature and output to the boiler as necessary. However, it is really more meant for the replacement of any B2HBs, CM2s, as these are legacy and on their sunset cruise right now to no longer be manufactured. We will, of course, support parts for years to come. However, if we do need to replace just one boiler in a plant, the Versatronik 503 is going to aid you in doing that. I'd like to thank everybody for your time today and your time every time you come to join us here for these webinars. And we will see you soon for the next one. I hope everybody has a great day, good morning, good afternoon, and maybe weekend, depending on when you're watching this.